Hi, we're going to talk a bit about event sourcing. So without further ado, let's see how we're actually going to use the 45 minutes that you guys chosen to spend here. Of course, there's mandatory introduction about myself and also a shameless plug for my company that is currently paying me salary. Hopefully, it also proves that whatever we're doing proves that the technology is viable for production at scale. Once that is done, we'll spend like 15 minutes talking about the theory behind event sourcing, and I'll try to give some trivialized examples. Then we'll spend like 5 minutes probably going quickly through the benefits and downsides that we as a company gain and have to suffer for using the pattern. And we'll get to the interesting part. So we've done our own implementation, and we'll talk about the scraped knees and the mistakes that we've made along the way. Finally, I'll try to leave 5 to 10 minutes to questions if you guys have any. So without further ado, let's move on to the shameless plug. This is our office in Vilnius. For a long time, we used to be called MobilePay, and we have recently merged with another company called Vips, so the billboard is outdated. Our marketing people spent a decent amount of time and effort trying to come up with a great name, and yeah, the best they could is Vips MobilePay. This is what we're stuck with for now. I think the name of the company kind of gives out the domain that we're working on. We're doing mobile payments. And we're originally from Scandinavia, so we have complete market dominance in the countries of Denmark and Norway, and we have strong presence in Finland as well. In total, as of now, we have more than 11 million active users sending money through our app. These 11 million users, in turn, generate more than 3 million transactions every day. So hopefully this proves that, yeah, event sourcing is actually viable for production at moderate scale, at least. When it comes to engineering, there's roughly 200 of us, somewhat equally split between all the 3 countries. Of course, like everybody else nowadays, we do microservices. We have, as of now, more than 100 of these. And majority, what's actually interesting about us as a company, majority of those services have been using event sourcing as their primarily means of data storage for almost 8 years now. Yeah, there's also me. My name is Tomas. I've been living off software for 13 years now. Throughout those years, I've had various different roles. So I've been a developer, I've been engineering manager, I'm now doing slides for you as an architect, right? I don't think this really matters that much. I tend to view myself just like an engineer. As long as you pay me a salary, I'll do whatever software-related tasks you want me to do. When it comes to personality, I think I'm as dull as it gets. So I'm not DJing, I'm not jogging, I eat meat and potatoes, I like a cold beer every now and then. I used to have hobbies, now I have a 3-year-old toddler, so that is far gone. I think the only thing that is even remotely interesting about me is I openly despise politically correct language. I think it makes conversations a lot harder without adding anything that's beneficial. I also think that us using complex terminology obscures the simple technical truths behind it. So partially due to those reasons, and also partially due to me not really being a native English speaker, I'll try to use simple language and illustrate with examples whenever I can. So pleasantries aside, let's start actually talking about the topic at hand. I would like to start the journey into what is event sourcing without defining what it's not. And the main reason for this slide to exist is when I was preparing, I read quite a lot of articles because I just didn't want to be that far away from whatever you can Google after the presentation on the internet, right? And the main thing that stood out for me that there's quite a lot of other optional patterns that these articles tend to mix in. And by doing that, they inadvertently raise the barrier for entry. So if my goal here is to convince all of you guys that event sourcing is easy and simple to use, yeah, they don't really give the best impression. So to illustrate that, here's the most used patterns and techniques that we in Vips MobilePay use when designing our applications. We do common query responsibility segregation, yeah, because of code cleanliness, separation of concerns, and easy separate scaling. We do quite a lot of domain-driven design because we tend to try to understand our business domain as well as possible, and we want to use the shared language with our stakeholders. We also do quite a lot of event-based or event-driven, so almost all the data between our apps is propagated asynchronously through RabbitMQ as of now, right? These things, they are great. I would never ditch them. But if you're just looking to start, they have nothing to do with event sourcing. It will make your entry harder. So for the purposes of this talk, I'm actually going to focus on the triangle in the middle, and we are only talking about event sourcing as much as possible. Good. What is actually event sourcing? First and foremost, it's a persistence pattern. So it describes how you should store the data that you have obtained. And the how is pretty simple. If in your traditional CRUD applications you are used to saving the current state, in event sourcing you instead store all the changes that ever happened in your business objects. Another feature of event sourcing is you're not allowed to neither delete nor modify any of the existing entries. So you can just add new entries as we go on. What this brings us in return is a thing called data loss free. In practice, this means whatever makes it into our database is highly unlikely to ever leave it. And this brings a lot of benefit for applications that are heavily regulated. So financial sector, there's a lot of compliance things you have to take into account. And you often get asked queries about the state of the system at some point in time. So that's why it's a good fit for us. So I've been speaking for quite a lot, and I promised you guys examples. So here's the first one. Let's take a look at the most trivial possible use case scenario for CRUD and event-sourced applications. So let's say we're managing users. User can have a name, phone number, and an email, right? So in traditional application, it goes something like this. A user onboarded. He didn't want to share neither phone number nor email with us. Then some time passes. He decides that phone number is OK. We get a phone number. We store it in a row, right? Yet more time passes. We get an email. We save it in a similar fashion. And then at some point, Peter decides to switch phone carriers. What quite often happens when you're switching carriers, you get assigned a new phone number. Peter shares it with us. And is there now at least a single person in the audience who could tell me what the phone number is? Typically, no. And in a while, we will not even remember that Peter switched carriers. So this is the exact problem that event sourcing tries to solve for us. Let's see how the same scenario would look like in an event-sourced application. So to begin with, Peter decided to onboard. We get a user-created event with all the relevant data at that point in time. So at that point in time, Peter was assigned an ID and has supplied us with a name. All the other data we didn't know anything about. Now, once Peter decides to share his phone number with us, we will get a new event. So his phone number changed. It changed for user 13. And here's the phone number that was supplied. Exactly the same thing happens with the email. And once the carrier changes, we get yet another phone number changed event. So there's two things that are straight away obvious. First of all, the amount of data keeps growing, so your storage is going to cost a bit more. And secondly, it's painfully obvious that not only Peter had a different email, different phone number at some point, but we also know what that phone number is. That, ladies and gentlemen, is the event sourcing pattern in the nutshell. But we still have more than half an hour, so we can get into a bit more details. If you decide to learn more about it after the session, you will unavoidably come to a concept of event stream. What is exactly an event stream? This time I'm starting with an example. You can see 3 event streams in here outlined in different colors. And the theoretical definition, it's an ordered set of events that represent a single domain object. So each of these sets of events represent one user in our system right now. If reading other articles, you might encounter a word aggregate. This is actually a domain-driven design term, but since domain-driven design and event sourcing are so often used in conjunction together, this terminology kind of bleeds into a lot of event sourcing articles. So when you see aggregate, yeah, it's almost the same as event stream. It can be used in place of each other. Last thing that I want to mention about event streams, they also serve as a concurrency boundary, but we'll get to this example in a few minutes. So it's all great, right? We all know how to store data as events. We feel smarter already. We're eager to try it out. What the hell just happened? I think I just deleted a slide. Ooh. You'll have to excuse me for a moment. Is there any chance we could maybe switch to the slides that you guys had, that I've uploaded? Because I think the part that disappeared is quite important. Oh, wait. It's fine, I found it. We're good. Yes. So first of all, let's take a look at what exactly is an event, right? You see a set of events above us in the screen, and they all have a shared set of properties. So first of all, they all belong to a specific stream, because as we talked, we represent business objects with a set of events, and we call that an event stream. So each event belongs to a specific stream. Furthermore, we also talked that the events inside the stream should be ordered for us to be able to make any sense out of it. So for ordering, we use a natural number, we call it a sequence. One could argue it's also possible to use timestamp, but there's clock skew and other things that discourage us from using timestamp as sequence. Later on, you might have noticed that each of the event has some properties attached to it, and that set of properties is really defined by what the event is. So there is no schema generic for an event. And in this scenario, data field is the dynamic payload that describes everything that's relevant to know for the event. Moving on, we have event type, and this kind of serves two purposes. First of all, it is a human-readable representation of what happened in our system. So yeah, you see user created. You know that this event represents a user being created. Secondly, it also can be used to deserialize, to know what to deserialize the dynamic payload to. So when I see user created, I know that I need to deserialize to an object that has an ID, name, phone number, and an email. Last but not least, we have a timestamp, and this is just describing when exactly did the change occur in our system. Yes, so the state thing that I've mentioned previously, right? In comes a PO, or BA, or however you guys in your company call the person who can monetize your coding skill. And he's saying that, yeah, it's all fine and dandy, it's very interesting, but I need the traditional UI where a user fills in where a user can see his name, phone number, and an email. How do we actually obtain it? Keeping in mind that we store the data in a way that we do. So we have a technique for this. It's called a projection. And once again, I think it's simpler illustrated with an example. We start off with a default model for what we want to return. So we have a user here initialized with default values, so 0 for ID and few empty strings. Then what we'll do is we will take the entire event stream and keep applying the events one by one on top of the model to get the current state. So let's go through this. We had a user created event with the sequence 0. And at that point in time, we knew user's ID and received his name. So we'll add it to a projection and move on to the next event. The next event is phone number changed. And we received a new phone number at that point in time. We'll add it. We do exactly the same with the email. And at this point in time, it might look like we're done, but it's not entirely true. What we have right here is what's called a partial projection. So this does represent Peter, but this represents Peter as he was as of 23/15, January 8th. So yeah, it's useful, but it's useful for looking up the state in the past, not the current state. To get the current state, we need to go through all the events remaining, and the last one remaining is phone number changed. We apply it on top, and that's the current state that we return for our UI to be rendered. Yeah, as already mentioned, there's multiple types of projections. What we have just looked at is called in-memory projection, meaning that we will get a request, we will load all the events, process them one by one at the time of receiving request, and return it. It's possible to make an optimization on this. It's called a pre-computed projection, also known as a read model. What this really means is we're doing the same, but not on request, but in the background whenever new events come in. And we generate a table where we store it so that when the request comes in, we can quicker respond with the projection that we already pre-computed. Yeah, and partial projection, as already said, it's for taking up a peek at how the state looked like in a distant past. So now we know how to store, we know how to read. How do we actually write? The writing part starts Painfully similar to the reading part, we also need state because we'll need to do validations, right? So we load the state the same way. We take all the event stream and take the properties that we need from the events. From there on, write models needs to accept requests for change. Sounds fancy. What it is a method. It says change email, and we accept a new email. We then need to ensure in our write models that whatever the state we end up with is consistent with the business rules that we have agreed. And for this purpose, I came up with a rule that if we don't really have a phone number, we don't allow to save an empty email because we would lose any way of being able to communicate to our customers. Yeah, we don't want it. So the validation is just throwing in case the business rules are not maintained. Last but not least, once everything happens, the write actually happens by emitting a new event. So there's a causes method on the class event stream. We'll take a look in a second. But that's how the change gets introduced into our data. Last thing, I keep mentioning this concurrency, or I mentioned it previously. What exactly is the issue with concurrency in our model here? I'll try. I love examples, so I'll move on with the example as usual. Let's say I myself decided to onboard on our system. So when onboarding, I supplied my name and my email. Later on, I was kind enough to share the phone number as well. But as it often happens in families, nothing is really personal, right? Me and my wife, we use the same home PC. So naturally, we're using the same accounts for a lot of times, or a lot of things. And at some point in time, both me and my wife, at the same minute, due to sheer coincidence, we decide to do changes. So I want to get rid of the phone number. She wants to remove the email. What will happen is our write model will load the current event source. So both of these events will be loaded, and we will end up reading the following state, where we have both phone number, email, we also have name. Then the validations will be checked, and yeah, the rule is that if the phone number is missing, email cannot be changed. But from the perspective of the code being executed, the rules are just fine. So both of these both of these methods will end up generating a new event. Both of these events, not necessarily in that order, but will actually end up in an event source. And lo and behold, we ended up in a state which is no longer valid due to rules that we agreed on. What do we actually do to solve this? I don't have any unexpected revelations for you. There's only two ways we can do it. It's either through pessimistic concurrency or optimistic concurrencies. So old concepts been there since the beginning of time. Pessimistic concurrency basically means that before doing a write, we would lock on something on the database on several rows, right? And do not allow concurrent requests that way. It's kind of optimized for a scenario where clashes are often, and we don't really want to pick this. Optimistic concurrency, on the other hand, means that we design our schema in a way that we will error out if concurrent writes are being done. Since, we don't really expect me and my wife to be editing same user at the same time that often, we rolled with optimistic concurrency in our implementation. And the way it's implemented, we simply place a unique constraint on combination of stream ID and a sequence. What this means in practice, if we take a look at the class that actually fires the event, what it does, first of all, it reads all the events from the database for a particular stream, loads the state, saves the events, right? When there's time to actually cause a new event, that new event will get assigned a sequence. And the sequence is based on the count of events currently read from the database. So if both me and my wife, when we executed the code, we loaded 2 events, both of us will generate the same sequence, and naturally we will end up with 2 different events sharing the same sequence. What happens next is we both try to store it in the database. One of us will of course succeed, while the other one gets unique constraint violation exception. So this is how we protect ourselves against concurrent writes. The last piece of theoretical slides that I had, I kind of had doubts whether to add it. It's reacting to events. The main reason why I had doubts is it lies in a morally ambiguous gray zone between event sourcing and event-driven. Because as I've described before, event sourcing is all about persistence, right? And reacting to stuff happening in your system, not that much persistence adjacent. At the same time, event-driven is all about sharing data across multiple different applications in a form of events, right? We're not really sharing anything, as it's just our application reacting to our own events. So yeah, it's a gray zone, and depending on which article you read, it's either event-driven or event sourcing. If, however, you do decide to go that way, what this gives you, it gives you a very clear separation of concerns between the actual rights, so user being created, and any side effects that might have happened afterwards. So a couple examples would be when user is created, we might want to send him an email notification congratulating him. Thank you for onboarding dear user, yada, yada. Maybe we want to generate a pre-computed projection whenever something happens. That's also executed as a side effect, so essentially a handle event function. What's dangerous about this is this seems very innocent, but it introduces a lot of complexity in our system because this is the first step from event sourcing towards actually having an asynchronous programming model. And with that comes two-phase commit, the dreadful issue that many of us are well aware of. Two-phase commit brings in two things that you as a team implementing need to be aware of. So first of all, you need to be intimately close with the concept of idempotency. And what it really is regardless of how many times the handler for sending out an email is executed, it has to result in only one email being sent because nobody wants to get 5 emails about the same thing. It sounds simple, but it takes a lot of effort, and when you have a lot of side effects, it gets complicated and tangled. Further on, you need to be aware that it's always possible for the first phase of the commit to succeed and the second to fail. So we will end up having situations where the event is persisted, but SMTP server is down or whatever, and the email doesn't really get sent. This is something you can't practically solve as an engineer only. If you want to solve this, you actually have to design your processes. So you need to involve your business stakeholders and build the process around the possibility of this happening. So yeah, this is nice, but it adds complexity on top of event sourcing. So I think we're done with the bare bones. Let's talk about what do we actually gain and what's there for us for suffering through this, right? First of all, it's very easy to troubleshoot a lot of common issues. So typically in CRUD application, whenever you need to troubleshoot something, you take a look at the current state and immediately diverge to trying to make assumptions about what led to you ending up there, right? In event sourcing, it's not a thing because the list of changes is our source of truth. So a practical example would be me, angry, calling to the support saying, you guys, what the hell? I haven't been receiving any of my bills in the email, even though I wanted to. What the hell is wrong with you, right? And the support person might take a peek in event source and politely explain to me that, yes, sir, you're not really getting emails because your wife on January 8th, she actually removed the email from your account and we can't really do anything without an email. So this solves a lot of time for us as developers trying to troubleshoot the issue. Second of all, I kind of stole this term from one of the articles I liked. It's called time traveling. In practice, what it is allows us through partial projections to easily answer queries about state of our system in the past. So let's say, once again, aforementioned PO comes in and says, look, it's crucial that you tell me how many of our users were using point of sale product in 2020. It's easy. I already have the data, the old data. I just do a partial projection up until 2020. We're golden. Moving on. Yeah, data lake is kind of a trendy topic nowadays. And it likes to get small chunks of data from all possible sources and then try to be smart about making insights on it. I don't know how they do it, but if they want to do it, it's very easy for us to supply them with the data because that's the form that our data is already in. It's in granular list of changes. We just take the copy of event source, drop it in the data lake, we're golden. Okay, and this one's an interesting one. Since you're actually saving the name of an event, so you're describing in human readable form what has happened in your system, it encourages your engineers to be well aware of the domain they're working in, not just shuffling values in some random columns in the database, right? So our experience is that when working with event sourcing, our engineers became domain experts in relatively quick amount of time. Last but not least, it's a competitive market, isn't it? So we can't dismiss this as well. Throughout the years, we have found out that engineers are resume-driven to some degree, all of us. And we like to work on technologies that nobody else is working on. In Lithuania, at least, there aren't that many companies doing it. So yeah, this has been a huge advantage for us and a benefit for the engineers when we are hiring. But just like with everything, there is no free lunch. And for all the benefits we have to suffer, here's what we have to suffer. So first of all, developers need to be upskilled. If there isn't many developers, many companies doing event sourcing, it means there aren't many developers who are competent and comfortable doing event sourcing, right? So we have to spend time teaching them. Ironically enough, from my personal experience, it looks like juniors and interns are way better at learning this because they're just like fresh clay, right? You can mold them into anything you want. They don't have any existing preconceptions about how things should or shouldn't be done. Yeah, but all developers with experience, you can also teach. It's just something that you have to take into account when deciding to do this as a company. Moving on, this is my personal favorite. I'll get into more details a bit later when we talk about fuck-ups. But it's actually hard and expensive to refactor applications that use event sourcing as their means of storage. Why? When you're refactoring traditional CRUD applications, so let's say the schema changes, right? What you have to do is you take the state as it is now, map to a state as you want it to be in the future. So it's a one-dimensional problem. When you're doing the same thing with event sourcing, you really have to take not only the end state, but all the intermediate changes. So all the history has to become valid. Depending on how many unique types of events can happen in your event source, right? This is exponentially higher problem. Just to illustrate, when I was a young and ambitious team lead joining MobilePay at the time, I was assigned to a team that had to do a refactory for one of simple services that we had. In the end, it took up 2 years for us as a team to do a refactory. It's amazing for me, don't get me wrong. Like, I got paid, I bought a car. I can speak about this during the conference. Like, my mom is probably proud of me. So for me, it's an amazing experience. For the company, 2 years, full team, not great. Yeah. Lastly, it's kind of odd because I also had this as an advantage. But developers gaining domain knowledge, it's not something that happens with the snap of your fingers. Right? It takes a lot of effort. What this means in practice, your team will likely spend only half of the time coding, and another half of the time they will spend arguing, is it user-created or is it user-onboarded event, right? So these discussions and domain discovery, they're extremely costly. It takes time, it takes effort. Yeah, it's a drawback. Cool, so now we get to the interesting part, the meat and potatoes. Where did we screw up, right? The way it was initially planned is I planned to just have several bullet points, just like in the previous slides. However, I quickly learned that there's way too many for me to be able to outline them all in a single slide. And what the reasonable person would have done is he would have probably removed the slide. I decided to keep it. Why did I keep it? I think the image here, it illustrates the idea very well. Like, there has been many, many scraped knees. We screwed up so many times. I can't tell you about all of them due to time and legal constraints, right? But the important part to take away, all of these screw-ups were no inherent fault of event sourcing as a pattern. It was a result of us trying something new for the first time. And if we were to actually implement it from scratch, there is no way we would step on the same rake. So hopefully, if you guys choose to try it out, this might be useful. So first of all, what do we actually model with event streams? Throughout my presentation here, I've been using user as an example, right? So it's a bit cheap. It's similar to using car or bike in OOP tutorials. It's something that everybody does because it's easy to convey the message that you want. At the same time, it's not really something you do in production environment. Well, why? So here is the part where we get to the 2-year experience I've had. I've just joined the team. They had a simple small service called Merchant, and they modeled a company as their event stream. This essentially represents a company that we, Vipps MobilePay, want to do business with, right? So there's some basic data, maybe taxpayer ID, maybe contact details, maybe company name. Yeah, and we wanted to keep that around, right? So we modeled a simple event stream, maybe 10, 15 events, pretty straightforward. What typically happens with software, if you don't fail at early stages, is you get feature requests. And majority of the time, feature request is just a request to automate a process of some sort. So we've added new automations for the processes that were already there and were manual, right? An example, we decided that there needs to be an automation for how we onboard our customers. Well, it's for merchants, right? So everything related to that needs to be added to the merchant event stream. So we've added like 10 more events about merchant state. Is it new? Is it onboarded? Is it pending onboarding? Then some time passes, and we realize that we need self-service. And not only that, there needs to be role-based access control because different people have different levels of access in our system, yada, 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 yada. Once again, it's user-based for our merchants. So we added the merchant event stream. I think I could go on, but I think you get the gist of it, right? Several years passed, and we're in a state where we have more than 100 unique events in that event stream. Our small microservice that we own is now over 90,000 lines, and vertical ownership is no longer possible. Each new feature takes ages to implement because the code base is convoluted. Essentially, turns out you can do spaghetti code with event sourcing as well, right? Sucks to be us. One more thing that we didn't really anticipate, and it's more of an exotic problem that we encountered rarely, but would have encountered way more if we were to actually scale higher before refactoring, is you might remember me mentioning that event streams also act as concurrency boundaries. Since we've crammed 18 processes in the same event stream as of now, this means that our users cannot answer KYC questionnaire at the same time as new users are being added. This means KYC questionnaire cannot be answered at the same time when our support is working on onboarding. It gets nasty. Like we managed to refactor before this exploded, but yeah, it was always an option. So what we did, we started modeling our event streams so that they represent separate processes. So whereas you had merchant state that was part of the merchant, you now have a separate process and separate event stream called customer due diligence. For the users, we have a membership process, and the list goes on. This is, of course, simplified, but in the end, yeah, we ended up with like 18 different, or close to 20 different microservices, which didn't share the database, had their own event sources, had their own code bases. This eventually ended up in, I think, 3 teams owning it rather than 1. Yeah, the problem was solved. As I mentioned, 2 years, probably best years of my life for the company, total crap. Okay, now we move on to another screw up, which I think is related to, in my opinion, the most fragile thing known to a man, which is developers' ego. So nobody's perfect. I've made bugs, you've made bugs. I'm planning to make some once I get back from the conference. They will happen, right? Natural reaction of any engineer when making a bug or discovering he has screwed up is, let's hide the body. Nobody knows, my reputation is intact. It's great, right? So how this materializes in the world of event sourcing is the developers start to do direct writes to entry to the row of an event. Let's say I've seen it happen before. I've taken part in a few of these necromantic rituals. I've only seen it succeed once, and it took 3 teams 4 weeks in total to undo the damage that was done. So let's not do that. Let's agree to not do that. Let's talk about why. Well, first of all, we claim that our system is perfect at tracking whatever happened in the past, right? As soon as we start editing data, we're obscuring that away. So we are losing those insights. Further on, we also talked that we like to have reactions, the side effects to be executed on top of our writes. It's very likely that you will not take this into account in a large system when editing the database directly. What needs to happen instead is a so-called compensating event pattern, and I have a small example of how it can be used. The fonts are not great, but I'll try explaining it. So we had a user that was a happy user, created and operating as usual. At some point in time, due to a certain developer, let's not name him, we unintentionally deactivated the user, right? Everybody noticed, or few people noticed, they started panicking. What do? Hide the body. There is no event, never happened, it's great. However, in realistic systems, you will have like 20, not 2 side effects, you will have 20, and you will miss some of them. In this case, the side effect is us sending a notification to a user saying, well, we'll set to see you go, better luck next time, and so on. And in comes a call to a support where the person is obviously not happy and asking, well, why the hell did this happen? Well, we don't know. we just described that we keep this all track of all of this forever, right? Yeah, we don't have any entries. Realistically or theoretically, you could say that, yeah, well, this will be just happened recently, the team will remember. In practice, it typically takes like half a year for these things to surface, and then you're in the world of pain. Yeah, there is no clue what happened, there is no entrance, no entries, and ages went past. So what should we do? Yeah, once again, same scenario. Somebody screwed up. We fire a new event that says, well, we now reactivate the user because Thomas made a mess of this. For me, it's a personal shame, right? And you kind of have to learn to get over. This way is better. You get to react to new side effects. You get to undo the damage you have done. And the traceability is there. Moving on. GDPR, everybody's favorite topic in the last 3 years, right? If you've paid attention, you might have noticed that we have, that I bragged about us using event sourcing for 7 to 8 years, and GDPR came into effect in 2018. What this means? This means that it caught us with our proverbial pants down squatting, and we were not ready. All of a sudden, we needed to be able to remove parts of the data, even though the core tenet of our architecture is never removing anything. What did we do? Right? We needed to be compliant. We went with the nuclear option, and when we need to terminate something, we just purge entire event stream, everything, nothing remains. It's a desert after that. Why is this bad? Well, it has a lot of collateral damage. I just bragged once again a few minutes ago about us being able to tell how many users used a particular product in 2020. Turns out, if you start purging the data, then you can no longer answer the queries, right? So we just lost a benefit, one of the main benefits that we had. What should happen is we should use cryptographic shredding, and we've started working on it. In the meantime, let's take a look at what it really is. So here's once again the scenario, happy user working for a while. We decide that we need to terminate this sensitive data. This is how it looks after termination in our system. So all the previous events are gone, obliterated, and the only message we have is user data terminated and ID 1, which ID is completely meaningless in this scenario because there's nothing related to that ID. What should happen is we should, from the get-go, encode every sensitive property with a unique key. That key, it should be stored in a separate table for laters, right? So that when the user decides he doesn't want to be friends anymore, we add a new event saying, yeah, the key deleted, and we remove the key. What happens effectively is we still keep all the sensitive data, but it's encrypted with the key that has since been lost. So until quantum computing kicks in, we're compliant. That makes me happy. Last but not least, it's a bit philosophical, but I think we went too hard on the event sourcing. We invested a lot and developed our tooling to such a degree where it became a de facto standard for any application in our company. So what we would do is we would apply it everywhere. You get an event source. You're writing an internal web page which needs 2 checkboxes. Yes, event source it is. And we start to apply it everywhere. And due to that, all of the drawbacks we discussed, they're also applicable. Development takes longer. There's a lot of discussions about how things should be named, even though like 4 people are going to see the web page. It's not great. So the outcome of this is we've started applying event sourcing on a case-by-case basis, which I think everybody should do. Right, so that kind of brings me to an end. And the last thing I want to talk about is the key takeaways. So what is the message I hope each of you guys have after leaving this room? There is no technical complexity in event sourcing. If you're proficient in at least one language in SQL, you can have a POC implementation in 3 days. It's easy, nothing complex. However, just because a hipster in a conference told you doesn't mean you should do event sourcing. That's not how decisions should be made in a large scale. So each and every case should have weighted the advantages and disadvantages through the filter of your use case and what you're designing, right? So there's a lot of benefit if you are actually writing an application that needs the history, that's sensitive to having all the history. If you don't, maybe it's not for you, maybe not worth the investment, right? Furthermore, even if you need the history, if you don't have a clue about your business domain, there is some pain you have to go through. If you don't have time to go through that pain and learn it, maybe it's also not for you. Last but not least, yeah, to fully benefit from event sourcing, it pays to adopt a synchronous model, and this is not a technical change, it's an organizational change on a broader level. So yeah, if you want to benefit, you should look into this as well. I think that's all I had. Well, we will have some time for questions, but after the time for questions has elapsed, I'm told there's snacks and drinks and the presenter's dinner. So I fully intend to absorb all the benefits. And if you're too shy to ask me now or I can't answer now, you'll find me stumbling somewhere around. So just approach. I'm happy to talk more. And that's it. Thanks for your time. See ya.
Thank you, Thomas. Thank you very much. Entertaining memes and great presentation altogether. Do we have any questions about events? Yes. Let me come.
I'm curious how the performance is affected when you actually have to take the data from the database and get it to a user in the front end. Yeah, let's say you have a lot of, states that changed over the time, and you have to build that projection that you said. You just take them step by step, build the current state, and then I'm guessing you get it to the user. If you have a lot of them, how does that affect the performance?
So it does, of course, and that's one of the reasons why it's recommended to not let your event streams grow to insane measures, right? However, we have ways to combat this. There's at least a couple. First of all, there's pre-computed projections that I already mentioned. If that's not enough, there's a pattern called snapshot, which means that every 100 events, we will take a snapshot of the current state and use it as a basis, right? So you'll take, like, if we have 653 events, I'll take a snapshot of the state from 600 and just apply the remaining 53. However, as I've said, we are running this in production now. It's decent load. Yeah, we're not Amazon, right? It's 11 million users. We don't do this at this point in time because we don't see a need. So it takes a lot of time for this to become an issue. And once it does, there are industry standard ways to solve it. So we shouldn't be really afraid of that.
Good. Yeah.
Hi.
Hey.
Regarding your GDPR example, you were saying that you are using a key in order to encrypt the sensitive data. But what about using that key from another table in order to decrypt the data? Is it GDPR compliant anymore?
So the key is there for the purpose of encryption, and it's there for as long as we don't have to invoke GDPR, right? Once GDPR gets invoked, the key gets purged, it doesn't exist, and we cannot really use it anymore. So yeah, I think we're, short disclaimer, we're not doing this yet. It's in the works.
Great. Yeah, we'll catch them all.
Can you tell a little bit more about these 2 years of refactoring? Because it's hard to imagine how business can survive. And did you ship new features while refactoring? It's really hard to imagine.
Yeah, ideally, I would tell you a happy tale about how we went to the management, explained the problem of not being able to work efficiently, right? And we got allocated time. This never happens. It's 2 years. Let's be realistic, right? So a lot of things can happen. My daughter was born during that time, right? You have to kind of work undercover to some degree. Let's just leave it at that.
Okay. You also mentioned that you use computed projections, yeah?
Yes.
And let's say if they are also persistent into some other databases, and let's say such databases are offline, or you, for example, use such RIT models to present data, so how you ensure that everything is synchronized when such failures happen? Yeah,
so if you're trying to use separate data stores, for example, right, and you can't ensure transactional consistency, there is no magical thing I can tell you. It just means that if it's a separate database, you have to embrace eventual consistency and the synchronous model. So just like I mentioned, to reap the full benefits, it's almost unavoidable to eventual consistency, asynchronous programming has to be there as a prerequisite almost. Alternatively, you can always use the same database, right? And then the problem has less chance of manifesting, not that it's gone altogether.
Do we have any more? One more we can take. Yes.
Yeah, so I'm curious, how do you manage the pretty much DTOs? So when we talk about, like with your example, that email updated, phone number updated. So is it like separate DTOs, but what if email and phone number has updated? Because you mentioned that you look into the database, you check the event type, and then you deserialize into probably a separate DTO. So when having this simple entity as a user, that's kind of, it's still some separate events might happen, but then with your example, when there is a merchant, and you mentioned there is 100 of events, so a lot of like stuff can happen. So yeah, how do you pretty much manage that?
Separate project mostly. Like yeah, the ideal scenario is don't let your single event stream grow to such a ridiculous extent when this becomes a problem. But there is once again no magic bullet. You have to have separate classes, some sort of segregation, right? And there's separate projects you can move and so on. But there is no way to make them disappear. It's there, it's DTOs, right? Every event is a separate class in our system.